Okay, this is F.BF.3. This is functions, and we are going to be building new functions, standard 3. A couple terms I'd like you to know. Please put these in your journals. And the primary focus of today's lesson is the parent function. And function is basically going to be a relationship between x and y values, your inputs and your outputs. And in this case, we are going to have a linear function where our points should be forming a straight line. Now, when we're dealing with building new functions, we are going to need someone to compare to. So the most basic one that we have is f of x equaling x. And I want you to know that this f of x really represents the y variable, the y coordinate, and we have this idea of y equaling x. So all of your inputs are pretty standard. You get to pick them. I guess I could start with 0, 1, 2, 3, etc. I could put the negatives in there if I wanted to. And I know that if x is equal to 0, and f of x is equal to it, they must all be the same. And here's the graph of that particular picture. If I'm looking at 0, 0, we have the origin, we have 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, and onwards. Okay, so when we're dealing with altering the function in any way, shape, or form, when we're taking that parent function, this is the one that we are going to be comparing off of. So the look of it, we are going from quadrant 3 up to the upper right, which is quadrant 1, and that is a positive slope right now. When we make alterations, they have this notation that says f of x when equal to x, that was our parent, what happens to the values in our line when we add a b, when we add a new y-intercept? All right, well, you can probably figure it out based on the work that we've done so far, that when we have y is equal to mx plus 3, where that line is going to intercept the y-axis. But if we're looking at a table of values, x, y, and comparing it to our parent function, which was 0, 1, 2, and 3, what is the difference from our parent to now our blue line, which is g of x equaling x plus 3? What happens to all of your original inputs? Good. You're going to be adding 3 to them. So x, which was 0, x added to 3 is equal to 3. 1 plus 3 is 4, 2 plus 3 is 5, and 3 plus 3 is 6. So when I graph my new line, I have my ordered pairs of 0, 3, 1, 4, 2, 5, etc. And we have this parent function, this parent line, this linear function, just translating 3 units upward on the y-axis. So we call this a translation. Now, if I look at the next function, h of x equaling x subtracted by 4, you could assume that you're going to take your parent values and then you are going to deduct 4 from your x's. So how would that look? So 0 minus 4 is negative 4. 1 minus 4 is negative 3, negative 2, and negative 1. And let's see where that's going to go. 1, 2, 3, 4. And then 1, negative 3 is 1, 1, 2, 3. Let's clear this parent out of here. Okay. And this line is translated 4 units downward on the y-axis. So the purple line is our parent. We're comparing the blue and the red based on the alteration of the constant number that we filled in there for our b. So this is a translation upward or downward on the y-axis. So there's your verbal description. All right, a new scenario. We are now looking at the parent, f of x equals mx, when your slope, now we're just focusing in on the slope. We're not worried about the y-intercept. The y-intercept b is always going to be 0 in this example. So what happens to this parent purple line when we have a slope that's greater than 0? So any fraction, any decimal, any whole number greater than 0, so, such as the red equation, g of x is equal to 2 times your slope. All right, so you can make a table of values, and you can see that we have our parent, 0, 1, 2, 3. I'm not going to draw that out again for you. What happens when we multiply all of those values by a new slope of 2? So 0 times 2 is 0, 2, 4, and 6. All right, let's graph that. So we share the origin, 1, 2, 4, and then we go up here to 6. Okay, now what happened to that purple line? It looks like, let me finish off this here. It looks like we have a line that is going upwards. It's heading towards the y-axis, and if we were to use a verbal description, this is called a vertical stretch of the parent function. So I have a little picture here for you that might help you. Okay, so the little puppy dog down there appears to be really stretching up towards the ceiling, and when you take this this red line, let me get this red line here for you, it also is stretching up towards the ceiling. All right, so that's what happens when your slope is greater than 0, and then when it's greater than 0 but less than 1, we call those fractions. What's going to happen to the look of this picture when we have a fraction for m? All right, so let's take out our table of values over here on the right, and you are taking a half of all these numbers. So a half of 0 is 0, and then we have a half of 1 is 1/2. Half of 2 is 1, and then we have 1 1/2. Okay, let's graph those two. So 0, 0. Let's use that. 1 1/2. 2 1, and then 3. And what do we have? 1 1/2. And we have this line that is below our parent function. So it's actually doing the opposite of stretching. We call that shrinking. Okay, so we're getting closer to the x-axis now. We're heading closer to the zeros of the x-axis. All right, so what did I have here? I had a little something I wanted to, where is that? Okay, right here. So let's be rid of all these annotations. And just another quick review of the idea of shrinking and stretching. So here's your parent function. When we're talking about stretching, our line is heading closer to the y-axis, and when we are shrinking, it's heading closer to the x-axis. All right, so just another visual there for you. All right, the last one is also dealing with the slope when we have a slope value that is less than 0. And the wording or the description that we use here, this is called a reflection. So if you see a negative here, we are talking about a reflection of the parent. And we also have the same ideas with the stretch and the shrink. So if I have a negative, let's just call this, for example, f of x, oh, what is that, a g? Okay, that's a g of x. So if g of x is equal to negative 2x, we know that the negative notifies us of a reflection, and the 2 will be still the stretch of the parent function. And then if I have h of x equaling the negative tells me that we have a reflection, and the fraction tells me that it's a shrink. So in this case, it happens to be negative 1/2, or you might have a different fraction of negative 3/4. So again, that would be a shrink, but reflected. All right, so the terminology that I would like you to be familiar with for these descriptions, we are taking these linear functions and we are either translating them upward or downward on the y-axis. Another common word could be a shift. We also have possibilities of a vertical stretch, a vertical shrink, or a reflection. So if you guys could jot those down, and when I give you some function equations, I'd like you to be able to put those into descriptions using sentences. Okay, in your journal, I'd like you to define the given terms and write a few sentences on what you think you learned from this video. And if you had any questions, let's bring those to class. We could answer those.